your eyeballs, please? Thanks, sir. Okay. Who wants to try H? Let's go here first. BMW, you want to give this one a shot? Okay. What side am I going to work on? Okay. So tell me what to do now. What's that?
Can you raise that smaller?
Yeah, sure.
Oh.
Yeah, that helped.
Plus one.
Good. Okay, make sure you're writing this all down. It's part of your credit, right? What do I do here? What do I do here?
I don't know.
Okay, this is what I want you to think, okay? You have $6 and you have 50 cents. Okay? Are they the same thing? They kind of are, right? $6 and 50 cents, right? Isn't this the same thing? We just put these numbers together? When you have a whole number and you have a fraction, just combine them. When I say combine them, just write them. 6 and 1/2. Let me see thumbs up or down if we got this. Just put it together. Just add the 6 to the half. It's no different. If you had $6 in one pocket and you have 50 cents in another pocket, you add them together, right? You took the part of the dollar and the total dollars and add them together, and it's that, okay? Nice thing is when you don't have multiple fractions in here, you just put them together and make a mixed number. Do we know what a mixed number is?
Yeah.
It's what? Yeah. Oh, no.
A whole number with the...
Apart. And so actually, just so you know, this is what a fraction is. It's part and it's whole. Let me explain this. If you have 1/4, how much of a dollar do you have?
4.
Right, because how many quarters make up a dollar? Okay, so 4 quarters makes up a dollar. And if you have 1, it's 1/4, right? No, take the hoodie off, take the hoodie off. Thank you. Take the hoodie off. It's a rule in my class, and I record my classes. Okay, good. We're good now. So if we wanted to convert this to a decimal, we could just put this in the calculator because division. 1 divided by 4 is 0.25, right? But we're not worried about this in this class because we keep everything fractions, okay? So if you remember this, fractions kind of make more sense because the part is always at the top, which is the numerator, and the whole is always at the bottom, which is the denominator. Are we good? Okay. So now I took care of all this, right? Now I'm going to have x over 8. So, what do I do now? What type of math is this? Very good. So what am I going to multiply this side by?
8.
Okay. How many get to this and say, no way? We're going to break this down. Remember what I told you about an improper fraction? Bacchus, stay with me, please. Bacchus, stay with me, please. Okay, we have an improper fraction, right? So we're 6 over 2. So do yourself a favor. Put a dot, put a plus sign, show the arrow. Yeah, 6 times 2, 12, plus 1, 13 over 2. Do we understand what we did?
Yeah.
We turned it improper. Now I'm going to show you why we turned it improper, okay? This becomes 13 over 2 and 8. Now, Mercedes, you get to say it.
Put a 1.
There you go. Can I reduce this?
Yes.
Yes, what can I reduce?
2.
How many times does it go into 4?
4.
Okay. Do these ones matter at the end of the day, Hector?
No.
Hector, stay with me. Let me see your eyeballs. Okay. Someone put in your calculator, tell me what the answer is. 13 times 4.
52.
You use the Peters calculator?
No.
Okay, are we done? Is this simplified?
No.
Why not?
Couldn't take away the 1.
Correct. We don't write it this way, right? But 1 times 1, so our final answer is 52, right? Okay. Are we ready to tackle this one?
No.
Yeah.
We're ready now. We're ready. No rules changed, okay? So what I gave you applied to every single problem here, right? We worked on the variable side. We simplified if possible. We did the inverse operation to both sides, and we always work with the variable last, okay? So looking at this problem, what side am I going to work on?
The variable.
Which is what? Yeah, the right. Okay, so knowing I'm going to work with this variable last, what I'm going to do? What's the opposite of this?
Addition.
Yeah, so write plus 3 over 2 plus 3 over 2. This is going to cancel out, right? Now guess what happens here? We have an improper fraction. Or excuse me, yes, we do have an improper fraction, but we don't have the same common denominators, right? So over here, I'm gonna move this h over because it's just going to get in the way. So we need this one to be 4, right? So we write 4. We need to bring this to a 4. What's 4 divided by 2? And what's 2 times 3? Isn't this the same thing? Someone say yes. Okay, now I can add these, right? What's 6 plus 3? 9. So 9 over 4, right? What do we have left in the problem? This part right here, right? Because we didn't do anything with this, so now we gotta deal with this. Okay, we know how to solve this, don't we? Don't allow fractions to throw you off. You just gotta, when it's adding and subtracting, you gotta get them proper. Okay? Would you, after we finish this one, do you guys want to do one that's not divisible by each other, so you can see that? Say yes. Your time to shine. It's Bach's time to shine. Bach and I are going to do one together, and you guys are going to be blown away. Yep. Yep. Definitely want to see all balls on me. Okay, good. BMW, what do I do now?
Oh, you put it 8
8.
and 3.
Okay. And then what do I do? Okay, can I reduce these? Now look at this for a minute. Let's take a second. Can we reduce both of these? Because 3 goes into 9 and 8 goes into 4, right?
Yes, sir.
So 4 goes into 4 once, 4 goes into 8 twice, right? And 3 goes into 9 how many times?
3.
How many times does it go into 3?
1.
Do these matter at the end of the day? They don't. What's 2 times 3? 6. So don't we have our answer?
Yes, please.
Make sure the ringer's off, please. Okay, any questions, or is there any I need to go over this? Again, Hector, let me see your eyeballs, please.
So you want
Hector, let me see your eyeballs, please. Thank you. You can sleep next year. I want you to pass the class. Are we good?
No, you want to do 8 times 3.
8 times 3, but we already reduced it, right? 4 went at 8, so we reduced the 4 to 1 and the 8 to 2. So 3 times 2 is 6. Do you see it? Okay, let's do an improper fraction real quick. It's Bach's time to shine. Baca, look at me. Ready? We're going to do, let's do, Baca, look. Here. Oh, I got you. You want to do 2/3, right? You want to do 2/3, and you want to, look at me, look at me. I got you, I got you. He wants to subtract 1/5. I like it. Baca, you got this one. Okay. So neither one of these are divisible by each other, right? So what is 3 times 5? 15. And what is 5 times 3? Good. What is 15 divided by 3? 5.
3.
Thank you. I do that all the time. So it's 3, right? So what do I multiply the 1 by?
3.
Okay, let's talk about this. 15 divided by 5 is 3. So then we take this number, what we do to the bottom, we do to the top. So 3 times 1 is 3. So this becomes 3 over 15. 3 over 15 is the same as 1 over 5, right?
Yeah.
Okay, what do I do here now? 15 divided by 3 is what? Okay, 5. And then what is 5 times 2?
10.
Okay, so are we ready to go to solve this?
13.
Oh! That's minus, right? This is plus.
17.
Right? Baca, look up. Look at me. Come on, sir. So 10 minus 3 is what? 7. Now, is this positive or negative? Do I do anything with that denominator?
No.
No. Okay, a couple things. A, if your denominators are not divisible by each other, you got to change both of them, right? You got to get to a common denominator to be able to subtract or add them. Okay? Are we clear? Now I want to show you one last thing. Let's say we have a whole number. Let's say we have 3. Baca just gave it to me. And then, I got you. Baca loves that 1/5. He's like, let's knock this out. So we're 3 minus 1/5. I'm going to show you a quick little. Is $2.04 the same
No.
No.
as $3?
Mm-mm.
So $2.04 is not the same thing as 3.
Yeah.
It is. So I'm going to show you a quick and easy way. You look amazing. Let's put it away. In your Peter's pocket. Quick, quick, quick. Thank you. Okay, watch this. You remember in grade school how we had problems like this? Remember when we had these? Or better yet, we had this? What did we do? Sometimes we borrowed and moved over, right?
No.
Yeah.
No.
Yeah.
I thought you were adding it.
Okay, good. So we're going to borrow from this 3, okay? We're going to borrow from this 3, and we're going to write 2 5 over 5. Is 2 and 5 over 5 the same as 3? Is $2.04 the same as 3?
Yeah.
Yeah. So we borrow from the 3. We need it to be a 5. That's 2. That part, that's whole, that turns into 1. That's 3. It's the same thing. So that's the easiest way when you're taking a whole number to a fraction, okay? We borrow from it, we reduce the whole number, we turn the fraction into a whole, now we can subtract. Not yet. 5 minus 1 is what? Bucky, your time to shine, buddy! What's 5 minus 1? 4/5. Bring down the 2. Learning amazing things today. Okay, let's talk about the do now. Flip over your worksheet for a second, your notes. What do I expect? All this should be written out in your notes, either on a separate sheet of paper or whatever, staple it together when you go turn it in, okay? This assignment that you're doing, okay, that's on the back side, it's not a lot of questions, but I can tell you half those questions, the exact same questions are going to be on the test tomorrow.
Oh.
So I just guaranteed you an F,
No,
right?
you listen-
You're at least going to get half of them, right?
If you listen to me when
I'm still going to have someone that gets a 0,
when I
unfortunately.
said, you were out and I was like, oh, you're not giving me a test on Thursday. You gave it to me on Friday.
The reason why I'm giving you a test this Friday was because when I watched the video from what happened in class, and North and South were in this quarter, and Ruben had his headphones and was on his phone, and Hector was sitting in the back row, right there, doing nothing. How would I know that if I knew he was sitting right there? How would I know this?
Alright.
Oh, Baca, let's not even go there. Okay, so we understand the steps, right? Let's talk about the do now, okay? Real quick. First, when you look at a problem, sometimes what our brain says, if we see something abnormal that we're not used to seeing over and over again, we get challenged and our brain tries to shut down, right? Or we go to selfie mode and we start taking selfies and this sort of stuff, whatever, Snapchatting, whatever it is you people do. So looking at this problem right here, right, we're going to follow the same rules. We're going to work on the variable side. We're going to do the inverse operation. We're going to solve this, right? Someone say yes?
Yeah.
Okay, let's talk about this one. Is this the same? Yeah, we're going to work on this variable side. We're going to subtract 1 from both sides. This one, subtract 6 from both sides. Divide by -2. This one, subtract 31. See the pattern? Let the calculator do the work here. Okay? This is 3. How do I know this? Because minus 0.3 and minus 0.3 is 0. So this becomes 3. I just gave you the answer to number 5, didn't I? Yes. Everyone should get number 5 right. Okay, so you want to do these, turn them in, and then you have your worksheet on the other side. Shake me out. Shake me out. Shake me out. Welcome to high school. Okay. Half these problems are going to be on the test, okay? This is what I would do, and what I'm going to open you guys up to real quick. Half of them, you don't know which ones, but half of these are going to be on the test. Half of these are going to be on the test, right? Half of them. So if you struggle with one in doing this when you come in tomorrow, I want you to circle it, and we'll go over 3 of them. Are you guaranteed to get 3 right? All depends if it's on the test, right? But if you're struggling with something and you know the rules, we will go over it right before the test. We'll pick 3 of them. Are we good? Okay, you guys know what you need to do?
Yes, sir.
Okay, make miracles happen. Yes.